In this final video, I just want to recap the major points of this entire series. To begin, if you're using a layered architecture, then you want to keep major concerns separated into their own layers of classes, right? Persisting data is one such concern that is usually separated out. It's usually relegated to a layer called the persistence layer or the data access layer. Now, while there are an infinite number of ways to create a data access layer, the repository pattern, and possibly the unit of work pattern as well, guides you towards creating persistence classes that have four important qualities. First of all, they keep the underlying data access technologies used in the application encapsulated and hidden from the other layers of the software, such as the domain layer. This persistence ignorance helps keep your software unit testable, and it allows for the possibility of swapping data access technologies out at a later date. Second, repositories keep query logic encapsulated in one or more finder methods, but the focus here is the encapsulation of the query logic. The query composition happens there as opposed to the domain layer. Third, they're unit testable because they don't leak their abstractions to other layers. And then fourth, they perform related inserts, updates, and deletes on a data model in a transactional context like we talked about in this series. Now, there's a lot of variation in how classes that claim to follow the repository pattern are actually implemented. The most simple and obvious is the specific repository style, or we called it also the custom repository style. In that style, only those methods that are required by the domain layer are implemented. Contrast that with a generic or abstract repository style, which define a common set of methods that all concrete repository classes must implement, or are actually implemented for them by a generic base class. In the architecture series on LearnVisualStudio.net, I promoted a domain-driven design practice that allows the problem domain needs to drive the design of the classes and their interactions. So true, the generic or rather abstract repository implementations require less code, but they usurp the authority of the domain layer classes in determining their data persistence needs. So in this series, I've tried to make a case for using the specific or the custom repository style, since it only implements exactly what the domain layer needs for data persistence. With regards to query composition, there are two querying styles, or rather two styles of finder methods. There is the simple repository style, that features many finder methods. Find by ID, find by year, find by make, find by model, and so on. And so each one of those are specific to a need in the domain layer. The second style is the specification repository style, which usually has a single finder method that accepts some query expression. Now in the .NET world, that's usually a Lambda expression, but it doesn't necessarily have to be. While the specification repository style seems to be more popular due to its convenience, all you got to do is pass in a Lambda expression, it is less unit testable, and the responsibility of data access and query composition leaks into the domain layer, which is, as we noted before, undesirable. In this series, I've tried to make a case for sticking with the simple repository style of many specific small finder methods that serve the exact needs of the domain layer. With regards to the scope of repositories, I talked about three variations. There's the one repository class per domain class, one repository class per aggregate root, and one repository class per bounded context. The one repository class per domain class style is seen most often in examples that also utilize a generic or abstract repository style because one class per domain class is easy to boilerplate, easy to abstract away. So when you have many repository classes, each providing persistence methods for their specific domain class, you might need to handle related domain classes in a transactional manner. This is the purpose of the unit of work pattern. A class that implements the unit of work pattern will keep a reference to each repository And then that class provides a single save or commit method. The save method, commit, will coordinate each individual repository's inserts, updates, and deletes as a database transaction in an effort to maintain the consistency of the underlying data. In domain-driven design, however, you think in terms of aggregates and associations, and then at the highest level you would think of an aggregate root. Therefore, instead of one class per domain class, you work with the aggregate root, which holds associations to other related aggregates. You then utilize a save method on a one repository class per aggregate root style persistence class to coordinate the inserts, updates, and deletes of all associated aggregates as well as the aggregate root itself. In this case, there's no need for the unit of work pattern because the repository class already has knowledge and a database context for all the aggregate root and its relations, and is therefore already handling these in a transactional context. Now, if you have a very large system, you also have to consider bounded contexts. A single aggregate root class could have meaning in different contexts, in different perspectives. So it would make more sense to split the responsibilities of such a persistence class into many persistence classes based on the bounded context, or rather the subsystem or the perspective within the larger system. So through this series, we also looked at the common practice of returning iQueryable of t from a finder method, and I talked about the reasons why you should shy away from this if all possible. I'm not going to go into the specifics, but generally not considered a great practice, even though many people still do it. And finally, we talked about whether you even need the repository pattern or even a persistence layer in your applications at all. The conclusion I suggested is that if you're architecting a large project with a long shelf life, then you should strongly consider the benefits it provides in order to manage change throughout the application's intended lifespan. However, if time to market is the driving factor for your development project, then you're probably less concerned about the ramifications of change, and you should probably then just go ahead, end the charade, just utilize the tools and the technologies that enable you to quickly assemble an app. This will usually require you to mix concerns across the layers. You're usually not going to do unit testing and things of that nature. All right, and so you do limit the lifespan of the app when you do such a thing. Okay, so we're pretty much done here. From here, I would recommend that you go on to the next persistence layer topic, which is unit testing the persistence layer. Since the persistence layer relies on APIs like the Entity Framework or ADO.NET or some other API that provide communication with an underlying database access technology, you're going to need to master the ability to create mocks and fakes that resemble those APIs in order to get at the heart of testing your query composition logic. So as we end here, I hope that this series was helpful. Even if you don't agree with my conclusions, that's fine. I hope that it was helpful to have your options laid out for you in this manner. So thank you.